Okay, welcome viewers. So in the last video lecture, we saw this thing that how to solve questions of a recurrence relation uh, where uh, where we have the form alpha raised to the power n. Okay. Now in this video lecture, we want to cover type 3. Okay, so what is type 3 problem? See, suppose that you are given here 1 by f of e, and suppose that here you have some polynomial function, okay, which is supposed denoted like this, g of n, okay, where gn represents a polynomial function. Gn represents a polynomial polynomial function. Okay, so whenever you see any polynomial function, okay, in that case what we do, we convert this e to 1 plus delta, and here we change this g to gn factorial. Okay, this is the notation for factorial polynomial. Okay, so gn star factorial. Okay, this represents a factorial polynomial. Okay, now after this, what you do, after changing e to 1 plus delta, uh, arrange the terms of denominator in ascending powers of delta, and apply binomial theorem for solving the problem. Okay, so this is how we can solve questions of type 3. Okay, now next, with the binomial expansion, which will be used for solving the question. I just tell you about those expansions. Okay? So various expansions of binomial, okay, theorem. So the very first expansion is this: 1 minus x raised to the power minus. This is equal to 1 plus x square plus x cube up to so on equal to 1 plus x raised to the power minus 1. So this is what? This is 1 minus x plus x square minus x cube and so on up to infinity. Then third one, 1 minus x raised to the power minus 2. So it is 1 plus 2x plus 2x plus 3x square plus 4x raised to the power 3, like this. And then fourth expansion, it is 1 plus x raised to the power minus 2. So it is 1 minus 2x plus 3x square minus 4x cube, okay, 4x cube plus on up to infinity. Okay. So these expansions will be used for solving the questions. Okay. Now I show you some questions. So question number 1 based on type 3. So suppose here you are given 1 by e square minus 2e plus 1, and suppose here you have only n plus 1. Okay. So what is n plus 1? N plus 1 is a polynomial. Okay. So what we do, we change this e to delta. Okay, but wait for a second. You see that here this denominator, it can be expressed like this also, that e minus 1 whole square. Okay, because this is the identity of e minus 1 whole square. Okay, and you change these two factorial polynomial, which is n raised to the power 1, okay, plus n raised to the power 0. Okay, now after this, change e to delta. So it is what? It is 1 plus delta minus 1 whole square. Okay, so here what do you get? N raised to the power 1 factorial plus n raised to the power 0 factorial. Okay, so minus 1 plus 1 cancel with each other. So here you are left with 1 by delta square. Okay, n raised to the power 1 factorial plus n raised to the power 0 factorial. Okay. Now, uh, as delta behaves like derivative operator when it is applied on factorial polynomial, so likewise 1 by delta square behaves like integration operator. So integrate this function twice. Okay. So I just show you in rough work that what is the integration of this function. Okay. So when you perform first time integration of this function, then it is n raised to the power 2 by 2. Okay, and when you again perform the integration, it is n raised to the power 3 by 3. 3 by 2 into 3, it is 6. Okay, so it is n raised to the power 3 factorial by 6. Similarly, perform 2 time integration of n raised to the power 0 factorial, so it is n raised to the power 1 by 1. Okay, then again perform the integration, so it is n raised to the power 2 by 2. Okay, so you just use these results, okay, these and results here. Okay, so when you integrate this function twice, okay, what you will get here n raised to the power 3 factorial by 6, okay, plus n raised to the power 2 factorial divided by 2. Okay, so if you like, you can leave your answer here, but if in the paper you are asked that convert it into general polynomial, at that time you try to convert it into general polynomial. Okay, now we solve the next problem. So the next question is this: 1 by e square plus 2e plus 5. Okay, suppose here we have n. So n is what? N is a polynomial. Okay, so you see that you convert this denominator in terms of delta. So it is 1 plus delta whole square, 2 times 1 plus delta plus 5 into 1. 1 can be written as n raised to the power 1 factorial. Okay. Now here apply a plus b whole square identity, which is a square plus b square plus 2ab plus 2 plus 2 delta plus 5 n raised to the power 1 factorial. Okay. Now after this, you see that what do we get? Here we get 1 by delta square, 2 delta plus 2 delta is 4 delta, 2 plus 5 is 7, 7 plus 1 is 8, okay, into n raised to the power 1 factor. Okay, now write this denominator in the ascending powers of delta. So first of all, write constant term, then 4 delta plus delta square, n raised to the power 1 factor. Now what you do, in order to apply the binomial expansion, make this first coefficient 1. So take 8 common from it. Okay. So here you are left with 1 plus 4 delta by 8 plus delta square by 8 into n raised to the power 1